Hi everyone, welcome to the second part of lesson 3.5. So in this part of the lesson, we're going to do some examples of proof using the two new theorems, which were angle side angle, ASA, and angle angle side, AAS. All right, so just as a review, when we're proving congruence using any of our theorems, what we're doing is we're looking for pairs of congruent sides and angles between the two triangles. So we're trying to make matches between the two triangles. And if we can get 3 matches between the two triangles, then we can probably show that they're congruent using one of our theorems. Okay. And in our toolbox, we have some things we can use to make the matches. So we might make matches from given information. We might just be given some matches, in which case we can just put those directly into the proof. Or we might be given information that allows us to then make a match from that information. We can use angle relationships like vertical angles or alternate interior. We can use the reflexive property, which says that things are congruent to themselves. We can use what we know about midpoints and things being bisected, and we know that in both cases we have something being divided into two congruent parts. And we can use what we know about isosceles triangles. So we know isosceles triangles have two congruent sides and two congruent angles. So all of that is the same as when we were doing proof before. Just included it here as a quick review. Okay, so let's do some examples of proof. Our first one, let me put a line down. For our first proof, we're given that angle R is congruent to angle S, and LR is congruent to MS, and we're asked to prove triangle LRT is congruent to triangle MST. So there's multiple triangles going on in this diagram, so a good place to start would be locating the triangles that we're working with, that we're focusing on. So the first triangle that we're trying to prove congruent is triangle LRT. So L to R to T would be this triangle right here. And then the second triangle was triangle MST. So M to S to T would be this triangle. So these are the triangles we're going to focus on and try to make matches for in our proof. All right, so now that we've located our triangles, we can start working on the proof. We should always start our proofs by looking to the givens. And in this case, we're given some matches right away. So we can just put those matches directly into the proof. So our first match is angle R congruent to angle S. So I'm going to put that in my proof. The reason for that was given. And I'm going to mark that on the diagram. So angle R is congruent to angle S. So I'm going to put the same number of swoops there. All right, I'm going to go back to the given. I'm going to keep going back to the given until I've used everything that's in the given. So the second thing in the given is another match. It's a pair of sides. It says that the side LR is congruent to the side MS. So that's a match, so it can go right into my proof. The reason I know that is that it was given, and I'm going to mark that on the diagram. So LR is right here, and MS is here. Okay, so we've been given 2 matches. We need 3 matches in order to conclude congruence. So we need to try to make another match on our own. And we might notice that right here in the middle, we have a pair of vertical angles. And we know that vertical angles are always congruent, so we can get a third match between these 2 triangles. All right, so we need to put this in our proof. We need to figure out how to name these triangles so we can say that they're congruent in the proof. So remember, think of the letters as outlining the shape of the angle. So I could start at L and go to T and then to R. So I could call that angle LTR. And that's congruent to, on the other side, I could start at M, go to T, and then to S. Angle MTS. Okay, and the reason I know those angles are congruent is that they're vertical angles. All right, so we have three matches. We have two angles and a side. So let's figure out which of our congruence theorems we might use here. Okay, we know we have two angles and a side. We could think about maybe if we go around the triangle like that, we have the yellow match, which is a side, the pink match, which is an angle, and then the green match, which is another angle. So that's SAA, but we could see that if we just write it in the other order, in the other direction, it's AAS. The key point here is that the side is not between the two angles, so we know it has to be in AAS and not in ASA. If you write it as SAA, that's also fine. SAA and AAS are the same. Okay, so AAS is one of our congruence theorems, so we know these two triangles have to be congruent. So that means we can put what we were trying to prove as our conclusion. So our conclusion is that triangle LRT is congruent to triangle MST, and the reason was AAS, angle side congruence theorem. Okay, so that's a first proof example using one of the new theorems. Let's try one more before you practice on your own. Okay, again, we have multiple triangles in this diagram, so let's orient ourselves to the triangles that we're trying to prove are congruent to each other. So the first triangle that we're looking at is triangle ABF. So let's find that. A to B to F, that's this triangle here. And then the second triangle is triangle ACD. So A to C to D. Okay, so we see that we have two overlapping triangles. We can work with them on the overlapping diagram, that's fine, but I always recommend that if you have overlapping triangles, sketch them off to the side separately, because it can sometimes be a little hard to visualize what's going on with the triangles when they're overlapping, and it can be easier to see what's happening when they're separated, sometimes. So this is something I recommend as a strategy to help you solve the problem. Okay, so that's going to be triangle ABF. That's the blue triangle over here. And now I'm going to sketch the purple triangle ADC. Okay. So we have our triangle sketched off to the side. Now we can start working on the proof. All right, step one, we go to the given. Always go to the given. And we're given some matches for free, so we're lucky. We can just put our matches directly in the proof. We're told that angle B is congruent to angle C, so we can put that in the proof. We know that because it's given, and let's mark it on our diagram. Angle B congruent to angle C. They have the same number of swoops. All right, next given is the side AB is congruent to the side AC. Also given, and let's mark it on the diagram. So A to B, and then A to C. And this side is an example of why it can be helpful to draw the triangles separately, because if I was trying to mark that on this diagram, I wouldn't know where to put the ticks. Would I put them here or here? If I put the ticks right here, it looks like I'm just saying AD is the side I'm putting the ticks on, when I really want them to be on all of AB. So that's why it can be helpful sometimes to draw the triangles separately. All right, so we've got two matches. We've exhausted the given. So now we need to make a third match on our own. And to do this, we're going to use something that we've used a lot before, but we've never used it quite in this way. So these triangles are overlapping, which means they share some parts. In the past, when we've had overlapping or touching triangles, they've usually been sharing a side, and we've said that side is congruent to itself by the reflexive property. We can also use reflexive property for angles, and triangles can also share the same angle. And in this case, if we look at the top of these triangles, they both have angle A. And we can see that on the diagram right here. Both of our triangles have that top angle as one of their angles. They're overlapping and they share that angle. So by the reflexive property, angle A has to be congruent to itself. And intuitively that makes sense. Angle A is the same number of degrees as angle A. So we can put that as a match in our proof. Angle A is congruent to itself by the reflexive property. So the reflexive property still means congruent to self. We're just now using it on an angle instead of a side. All right, so we've got 3 matches, so hopefully we have enough for congruent. Let's check the order of our matches. If we go kind of across the triangle, maybe like that, it goes green, yellow, pink. So the green match is an angle, the yellow match is a side match, and then the pink match is an angle match. So it looks like we've got angle, side, angle, which is totally enough to conclude that the triangles are congruent. So we can put this as the conclusion in our proof. Triangle ABF is congruent to triangle ACD, and the reason is the angle side angle theorem. All right, so those are 2 examples of using our new theorems in proofs.